Okay, so we're going to move on to our next one, and I need you to pay attention to this pattern. Keep using this term, they're cooked up. There is a trick to doing this problem, and many others. So there's our arc length definition again for when it's y equals f of x. So we're going to find the length of the curve, f of x, which is equal to 2e to the x plus 1/8 e to the negative x on the interval from 0 to the natural log of 2. And this may seem disgusting over here, but there's a reason why it's set up as it is. Let's check it out. So first, let's just set up our game. So we're going from 0 to the natural log of 2, and it's the square root of 1 plus our derivative squared. So let's go find its derivative. Well, that's 2e to the x. And that e to the negative x is just going to change the sign and give you 1/8 e to the negative x. Cool. But I don't want to do the full square. Let's do it outside. Let's do this outside, and then we'll bring it in. So let's square this up. What is that? 4e to the 2x. Actually, let's do it the long way. Let's do it the long way. Sorry. I keep jumping steps with y'all, but I want you to see kind of the nature of this. So the way we square something means write it twice and then FOIL. Okay, so what do we get here? 2e to the x, so times 2e to the x, so 2 times 2 is 4, and e to the x times e to the x is e to the 2x. Now we bring it over there. E to the x times e to the negative x is 1. So we have 2 times negative 1/8. That's negative 1/4. Okay, let's do it again. Oh, that's the same thing we're multiplying together. So that's going to be minus 1/4. Lastly, we're going to take negative 1/8 times negative 1/8. That's positive 1 over 64. And e to the negative x times e to the negative x is e to the negative 2x. Once we clean it up, we have 4e to the x minus 1/2. Now that half means everything. That means everything. Now before we even put it in, notice that we have a 1. What's 1 minus 1/2? Positive 1/2. These are cooked up. So we're going to put this in, 4e to the 2x minus 1/2 plus 1 over 64 e to the negative 2x dx. So when we put these two things together, we're going to get the 1/2 minus 1/2. Now I'm going to put this in the same order. I want to leave this 4e to the 2x right here out front. And now we'll do our 1 minus 1/2 for positive 1/2. And then we have our plus 1 over 64 e to the negative 2x dx. Now do you see it? Do you see why this is cooked up? What would this have been? Just over to the right now. Remember how we squared up our f prime? What would have happened if this was 2e to the x plus 1/8 e to the negative x when we squared it? What would this turn out to be? Well, that would be 4e to the 2x. Sorry, I'm going to jump the steps. Instead of having negatives down here, remember we had negatives? We'd now have positive 1/4 and positive 1/4 plus 1 over 64 e to the negative 2x. This would have been 4e to the 2x plus 1/2. Only the center term would have changed. So this is, oh my goodness, that's what we have in our integrand. Or actually, it's in our radicand, which is inside of our integrand. But this is purely just equal to 2e to the x plus 1/8 e to the negative x all squared. That's what's underneath our radical. They have to be cooked up in such a way that you're going to be able to integrate them. This trick will be used multiple times. So this becomes 2e to the x plus 1/8 e to the negative x. Telling you, you're going to see that over and over when you go through and do your homework. If you don't have that pattern down, you're going to continue to get stuck. You get that 1/2 and you're like, it's that trick. Well, after we take the square root and the square off, we just have 2e to the x plus 1/8 e to the negative x. Oops, that's a natural over 2. dx. And we can keep it all positive. Don't have to worry about absolute values or anything because this is an arc length. We know it's going to be positive. We're not going to take a negative length. And now let's integrate. I mean, I guess it's a u sub on the last one. So the antiderivative of 2e to the x is just 2e to the x. And now this is a u sub, but dude, it just changes the sign. It makes it minus 1/8 e to the negative x. If you want to go through and do the u sub, you go right ahead. And now we're going to go through and evaluate. I really hope you catch this trick, that 1/2 trick. It's going to happen. So what do we have? We have 2 e's to the ln of 2 minus 1/8 e to the negative ln of 2 minus 2e to the 0th minus 1/8 e to the 0th, or the negative 0th if you prefer. Well, this is pretty convenient. Uh-oh, the machine's getting hot. So this is going to be 2 times 2. But this negative exponent, we need to bring it up to the top. This is 1/8 e to the ln of 2 to the negative first power. We have to have that trick down. We have to have that trick down. So now the e to the ln's can cancel out. You have 2 to the negative first power. 2 to the negative first power is just 1 over 2. Now we can run through and finish our problem. So we have 4 minus 1 over 16 minus 2 plus an eighth plus an eighth plus an eighth. 2 16ths. You see it has to go together, right? So what do we have? 4 minus 2 is 2, and negative 1/16 plus 1/16, that's just a 1 over 16. Let's get a common denominator. So you got what, 32 over 16 plus 1 over 16, and we get a nice, beautiful, clean answer of 33 over 16. That's typically about as clean as they get. But dude, look at all that work. Look at all that work for one problem. And this is a fairly standard problem. It's fairly standard. Granted, I explained a lot of it, but back to it. If you end up with a center term on the derivative that's a negative 1/2, this is the trick. Oh my goodness. 1 plus negative 1/2 is positive 1. And that's going to be our trick to be able to create a perfect square underneath our square root. So be ready for that. Handle business, dude. All right. Well, in our next one, I think we'll maybe go about some other stuff, you know? Check her out. See what we can do. All right.